Okay, we start with what we were doing, and let's look again, once again, a PNP transistor. We have already found the terminal currents for the bipolar transistors, both in the case if delta PC is taken 0, or if it is not taken, a longer expression. Both expressions are available, whichever you wish to be, you can. However, two more interesting things we must look into, and that is something like this. If I plot, let's say I am in a situation which I call normal mode of operation. That is, VBE is forward bias. VBC is also reverse bias. This is called normal mode of operation. So if I plot the current versus VCE, and that's very important. Why I call VCE is this: if you see a typical transistor in common emitter mode, and let's say I put some load resistance RC with a power supply of VCC. So you can see if this is forward biased, this is VBE, this, remember, this is N, this is P, and this is P, and I have forward bias. If the polarity is plus to the emitter and minus to the base. I reverse bias the base collector junction. This is P, so I must have negative here and positive here. Is that okay? So VBC is negative, reverse bias, and VBE is forward bias. Now if you see a circuit wise, and if this is the voltage I declared as VCE, I see by simple logic, simple electrical circuit, VCE is VBE plus VBC. I can go to this node, let's say from emitter to collector like this, or I get to emitter to base, base to collector. Either way, if I reach the collector node, the voltages must be same. So I go via base circuit, or I go via directly to the collector from emitter, the two must be same. Yes. No, VB is anyway grounded. VB is forward bias means with reference to some common voltage, which is in this case emitter, which is grounded. So V, base voltage with reference to emitter, is VBE. Collector to base voltage is VBC, so VCE must be sum of the two. Two batteries, plus minus, is that correct? Okay, that sign, as I say right now, I am not saying anything. So the point I am saying, physically they must add. This is in series battery, it is something like this. So it is addition of the two voltages. And we say collector base junction is reverse bias, base emitter junction is forward bias. Now in this case, the interesting feature is, if I now plot IC versus VC characteristics, IC is the current flowing in this, and let's say IB is the current flowing in this, and of course therefore I is the current flowing here. We want to know if I increase VCE for a given value of IB. So our relationship says, with this kind of features, we have derived all our IC, IE, IB values. Please remember, in all our analysis right now we have assumed, except when I say delta VC could be anything, right now assume that base collector is reverse bias, base emitter is forward bias, normal mode. So I say IC is beta times IB. Sometimes you call 0 to make it DC value. But right now don't worry too much about AC, we'll come back to AC later. So collector current is beta times the base current. Is that clear? So for a given beta IB values, which of course I can always choose, let's say battery I put or voltage some source called RBB, this is VBB. So what is IB current, can anyone suggest? VBB minus VBE by RBB is I. Circuit wise, voltage in this loop must be 0. Total sum of voltages in this loop must be 0. So VBB minus VBE divided by RBB or RB is base current. So externally I can always control the base current, because typical VB is, as long as we assume right now for the circuit purpose, we have already proved, otherwise we can find, typical value of VBE in this kind of mode is around 0.7 volt. So if I put 5 volt here, 5 minus 0.7 by some 100k, I know how much is base current, microamp, 10 microamp, 20 microamp, 30 microamp. If I am given a beta value, which is given from which, how can I get this value, even calculate? If I am given base width, lifetimes, alphas can be calculated, so is betas can be calculated. So beta is also known to me. So I know how much IC I'll flow for a given base current. Is that correct? Since I know my IC circuit wise, please remember this VCC means essentially going to the ground. This is battery, the other terminal is to the ground. So can you tell me what is VC value? VCC minus ICRC. The drop across resistor subtracted out of power supply is the remainder voltage. Now here is the problem which we like to see before we go ahead. Let us say initially base current is 0 or very small. Initially input voltage is 0, so to say base current is 0, is that correct? So the collector current is also 0. Is that correct? Base current is 0, collector current is also 0. Now that essentially means, if you say this VB is less than 0.65 or 0.6, which is the turn on voltage for the diode, this junction is switched off. That is, no holes are injected from the emitter towards the base, because there is no voltage to support it. Is that clear? And therefore there is no collector current, because there are no carriers coming from emitter which can reach except the reverse saturation current, which can flow. Even at zero bias, reverse saturation current can flow. So if I see the characteristics, even at IB, maybe very small current, which I later will explain, is called the collector saturation or open circuit collector. We'll define this later. For a case, this is ICO, and this is the case when IB is, this can also be said to be, if this is reverse biased and this is reverse biased, no holes are injected, minor small electrons and holes can do, which is reverse current of the two junctions, and whichever is smaller, that will flow. Okay. In a circuit, there cannot be two currents. Whichever junction gives lower currents, that will be the net current coming out. Is that correct? Now if that is so, this is very small current. The device is said to be in switch off mode. What is the mode I am talking now? Switch off mode. Base collector junction is reverse bias, so is base emitter junction is reverse bias. Equivalently, no current across emitter to collector, and therefore we say device switch off mode. Now if we say device is in switch off mode when IB is 0, transistor is off or cut off mode, as we say. However, if I increase the base current, Is that correct? If I increase the base current. What I am trying to show you, how device sees external circuit changes. So far we thought as if device is doing something. No, I can only have control on external circuit. If I change external circuit, how device adjusts itself. What is it now saying? If you say VBB increasing, so that there is a sufficient IB flowing through this, and if IB has to flow from here, obviously there must be recombination in the base, which essentially means some holes must have appeared from the emitter junction and most of them have passed to the collector and small amount have recombined to give me base current, which means base emitter junction must have sufficiently forward bias to create reasonable number of holes coming from junction injected into base. That's why I say VB increasing means essentially say it is active mode in which there is sufficient holes are now available for transit. Now this means if I increase IB and if this is now means we are now reaching this, earlier both were reverse bias, now one is forward bias, other is reverse bias. This relation holds, that's what we have derived. If this relation holds, there will be a collector current. Is that clear? There will be a collector current. If there is a collector current, this drop will increase. ICRC will increase. So VC will fall. Is that clear to you? VC will fall if I increase base current, VC falls. What is the maximum current this circuit can have from power supply to the ground? Assuming that VC is 0, which is the least VC can go probably, then we say the maximum IC which, or sometimes write IC max as they say, which I can flow in this circuit is VCC by RC. That's the maximum current power supply can give you, assuming VC is 0. If VC is little finite, you will never even reach IC max value full of it. But you may come closer to it, depends on VC, smallest value you can attain. Is that clear? Now this VC is something to do with this. What is happening therefore? If I change VBE, this value adjusts to get this drop. Because externally I am forcing things to happen. The VVC and these two happen such that VCE goes down. Is that correct? This is what circuit is doing. Please remember what I am trying to say. So far we say change the voltage of device, so what currents I get. Now I am externally seeing a result because that's what circuit I will see. And I see, oh, VC is dropping. So I say VC dropping must be VB plus VBC must be dropping, otherwise why should VC decrease? Okay. This occurs because that IC/RC drop keep on increasing as the base current starts rising. Is that correct? There is this equation which is shown here. If I plot it on this is, what is it called? This is the IC max. This is called load line. This relationship can be plotted on this like this. What is the slope of this? 1 upon RC. Okay, that is called load line. Is that correct? Now this load line is essentially limiting the currents. Is that correct? The load is limiting the currents. Is that correct? So I am trying to now today, first I am telling you that circuit wise how device adjusts. Is that correct? If I see external something, what is device doing in? Okay. Earlier we said, okay, do I do device something, what I see, okay, externally I am doing something, let's see what happens inside. If that happens, I keep increasing IB further. So this is the VC values, keep on decreasing as IC increases. As IC increases, these are the values which, so at every time I change IC, I see different IB values. This is IB1, IB2, IB3, IB4 and so on and so forth, and IBs are increasing. So if IBs are increasing, IC is increasing. If IC is increasing, VC is getting down, which is because every point at every IB, you can see there is a different VC is reducing. Is that correct? Now the problem starts somewhere ahead of it. So as long as this relation holds, as long as this condition is held, as long as base emitter junction is forward biased, base collector junction is reverse biased, IC will be proportional to IB by beta times. Now what is going to happen further? If I now see, I further increase base current, because base current can be independently controlled by me. I just increase VBB or reduce RBB, मैं IB कितना भी कर सकता. Let us take a typical value. Let's say this is 5 volt and this is 1 kilo ohm. So the IC max in my case is 5 milliamps. Is that correct? Maximum current which this circuit can allow on the output side is 5 milliamps. However, let's say I choose some value of VBB in which I can make IBB as large as 100 microamps. Let us say beta is 500. Maybe even higher than 500, I may say 1 milliamp for the sake of poor example. So how much is this should give me? IC of 500 milliamps. You said I can always get to higher base currents. Is that correct? I increase externally VBB. Base current बड़ा. Beta 500 है. So 500 into 500 milliamps. But you just now said for this load the maximum current I can get is 5 milliamps. That means something must have happened that this relationship IC is not equal to beta IB must have taken place. Is that clear? If I keep increasing the base current, what is the maximum base current I can flow for active mode then? Say 5 by 500, okay, so around 1 microamp or whatever, 10 microamp current is the maximum base current I should increase. But I externally can go beyond 10 microamp. Well, who can stop me? I increase power supply. I may go to amp, milliamp, anything inside. But now the circuit cannot sustain more than 5 milliamps. Is that correct? So this relationship which was trying to tell must be now such that the reduction in this must have occurred only if the polarity of base collector junction is reversed. Because then they will oppose each other and VC will keep down reducing, at best going to 0, which is not possible because there is a resistor, some drop will always come. So one always see that base collector junction and base emitter junction both gets forward bias, though externally we are still putting it reverse bias because for a PNP the polarity is kept, otherwise there. Is that clear to you? So this is very interesting thing happened. Device internally got opposite polarity. Is that clear? That means both base emitter junction giving forward bias, you can see what it can do then. If both are forward bias, this will inject, this will inject. Huge carriers will come from collector side and also from the emitter side, and therefore the base current starts increasing because excess carrier, excess electrons must come in to actually neutralize. Okay. That means increase of base current beyond this value essentially means the base collector junction internally gets forward bias. So what circuit can force you though external, remember this is an NPN transistor shown, so that is why the opposite polarities I was talking, plus is going to end there. sorry, I should have made, sorry, mistake. This is NPN transistor, okay, and that is why the polarities are like this. So it should be opposite, but anyway, that polarity sign is opposite for everywhere. So essentially what I am saying, that initially both junctions could be reverse biased. As I increase IB, the base collector junction is externally reverse biased, base emitter junction is forward biased, IC start flowing, VC start decreasing, but if you increase further your IB, to sustain that larger IB, because you have increased IB too much now, so what it does, the base emitter junction and base collector are both forward biased and push huge currents. Is that? But when that happens, since base collector junction is forward bias and base emitter, this does not then allow me to use this relation, because this was derived only on the basis that whatever emitter is injecting is collected collector end. Now this is not happening. Is that correct? So that is the maximum current you can achieve by reducing VC. Typical VC which you will get for this close to this will be of the order of 0.1 volt or 0.2 volt. This small values of VCE, 0.1 or 0.2, forces as if to say both junctions are forward biased and therefore no relationship between IC and IB as far as beta values are concerned, because both are now forward biased. When this occurs, we say you are in region of saturation. When this occurs, here also you can say. So which is this region? When IB is 0 mode. Okay, it's called cutoff. What is this region? When base emitter junction is forward bias, base collector junction is reverse bias, we say you are in normal mode, or also in circuit we call active mode. And if you are in this region, when IC is large enough, you are in saturation. What is being saturation? Collector current is now getting closer to maximum, saturates there, increase any base current now, no more change in IC can occur. Is that correct? You say collector current is saturated. Please remember why I am keeping you this. Earlier in MOSFET, I kept telling this is saturation, this is saturation. In in the bipolars, we suddenly change the names. Is that correct? This fact has to be understood. What saturate we say. There we say linear region, here we say saturation region. There we say saturation, here we say active mode or normal mode of operation. Is that clear? And what is the third one? Cutoff. You have seen from here that if instead of this, if I put a pulse here, 0 to 5 volt as I showed you, this is 5 volt let's say. At 0 volt, no collector current, let's write down this. At 0 volt, no collector current, transistor is off. So VCE, which I now may call V output, and this is called V in. So I say VC is VCC, V in is 0, so IB is 0, therefore V is VCC. IB enhances, increases, but still this relation is holding, beta IB, then V out will be VCC minus beta times IB times RC. Okay. Further, if I increase IB further, IC is not equal to beta times IB, but is equal to IC maximum, and then V out is VC minimum, which is typically 0.1 or 0.2 volt depending on what current levels I operate. So if I see the pulse, input was going from 0 to 5 volt, IB increasing means this VBB is 5 volt. If this is going from 0 to 5 volt, What is the output going? At 0, I have VCC. VCC, is that correct? 5 volt, I have a 0.1 or 0 you can say. So if input goes from 0 to 5, output goes from 5 to 0.1 or 0.2 kind of thing. So what has happened to the pulse? Inverted, and therefore this is called bipolar inverter. Is that called? This is called bipolar inverter. Where do you actually go from in the bipolar inverter? Because a step input, which areas you traverse? You are here or you are here. You only transit through active mode because the voltages are rising very fast from here to here. So you quickly go through the active mode and reach saturation otherwise. This is essentially the digital circuit inverter, because there I'll put in 0, 1. This 0 to 5 volt can be declared as 0 and 1 value of a digital base logic. So I'll go to 1 and 0 for the output. So I got inverted pulses or inverts, or logically I invert the input. Is that correct? 0 becomes 1, 1 becomes 0. So this is what essentially an inverter is. So now could you get it? That this circuit part, why did I show you? Because externally I'll always use circuit. I'll put resistor, I'll put values, power supply, everything. Device must get adjusted itself internally to see the performance you are seeing. So all this time we keep saying, okay, put BBE, put this is the current. So I today wanted to show you the external circuit essentially forces device to operate in various zones. And but which were those various zones? This theory which you got here was derived from understanding of a bipolar device, and from there I know if I put such an input, I'll get such an output. So I can now use this as an inverter. Inverter symbol we know is something like this, V in, V out, okay, and that is always equal to V in bar. This is an essential feature of a bipolar transistor, that we operate in 3 modes: cutoff mode, active mode and saturation mode. In digital circuit, I will switch to cutoff. Whereas in analog circuit, and that's what I will see, we will all, why do I want to say that? I'll always remain in active mode. What is the feature of active mode? This. Is that correct? So if I change base current small, collector current so many times will change, 500 times, 600 times or 100 times it will change. So I am seeing an amplification going, and input signal will get amplified by beta times equivalently, saying as if, because collector current will proportionately rise, device will still remain in active mode. This relationship therefore can be only held if device remains in active or normal mode of operation. For analog circuit, we'll always put the device in active mode, okay, and in digital, you buy pulses, it will always go from cutoff to saturated and saturated to cutoff, though it will traverse through active mode both ways. Okay. This fact has to be. The only thing why we don't calculate, because this time taken is practically very small, and as small as possible. We want probably 0 if you wish, but it may have finite time. That is what speed of a inverter will decide, how fast this can transmit. Is that clear? So this is an issue which you must understand. Device does not say anything. If circuit decides, then device has to adjust poor way what circuit is asking. Is that clear? So don't think that devices always decide. No, device can think I know everything, but at the end external people control all of it. Is that correct? So please take this, because I thought that so far I always talked about device, so you should not feel that I have no relevance what I am going to do in next semester courses. I have the strongest influence on everything what I do there. Therefore I want to know where should I work, so that my performance of analog and digital is known to me and controlled by me. Is that clear? That's why devices courses are taught. Okay. Many times this issue is always asked why. तो why इसलिए है. Okay, एक और issue इसी के साथ figure के साथ दिखाई. There are this characteristics maybe we'll draw again. आज जो करना था वो छोड़ के मैंने कुछ और ही कर दिया, but ठीक है. I have planned something more different, but anyway I thought this is more relevant immediately. If I plot this IC VC characteristics of the circuit as shown here, it somehow feels this is the characteristics I normally get, okay, actual experiment. But my relationship was telling this. What was my relationship was saying? IC is beta times IB. So if this IB, delta IB and this delta IB is same, then, delta IB, then the current should double, okay. But I figure it out that depends on I am here, or I am here. The change in IC is not same for change in same IB. Is that point clear? What is that issue I am talking now? Ideally I was expecting a characteristic something like this. Constant characteristics, so change in IB will be proportionally change in beta times IC should appear there. But in reality if I see a characteristic like this, IC for larger VCE values, the change in IC is more than change in IB. That means what has increased? Equivalently as if beta has increased. Is that point clear? Last people, I repeat. Let us say this all are delta IB, so corresponding to whatever every time IC 3 or whatever it is, change in IC is proportional to change in IB, so beta is constant. Is that correct? But if you see here the gap IB is still same, but IC is here and here, everywhere is not same. That means IC by IB or delta IC by delta IB is not constant. So what is this beta should be called? AC beta, because it's varying with where you are operating. Is that correct? So that is the difference between IC by IB and delta IC by delta IB. Therefore beta ACs are not exactly same as beta D. But why this is occurring? This occurrence is something interesting. When I say I am in an active mode, if I increase VCE, VB is constant forward bias 0.7 volt or 0.725 volt. That means I must increase reverse bias VBC to increase VC. If I increase reverse bias this value, this is now plus minus, this is VBC, larger the reverse bias, what will happen to the depletion layer of base collector junction? Initially at smaller value, this was the depletion. If I further increase VBC, negative reverse bias, this will occur. So, though base doping is larger than collector doping, but it's not very large, it's not as much as emitter. So, it is still lighter doped compared to emitter. As I said, 10 to the power 16 or 5 10 to the power 16 is a base doping. Is that clear? Which means some depletion will always come in base side. This is your initial W, base width. But as I increase VBC or reverse bias, what is now base width is? The actual base width, W effective is W minus XD if this is my depletion width, which is a function of VBC. So larger the VBC, larger is the XD, larger is the XD, W effective is smaller, base width becomes smaller. You recollect yesterday what I was talking, this W by LP ratio, smaller it is, gamma and alpha T both are close to 1. Yesterday we did discuss alpha will tend to 1, alpha 0, or essentially alpha T will tend to 1, gamma will tend to 1 if W by LP is much smaller than 1. Is that clear? So larger the VCE, which is function of VBC, larger the VBE, smaller is W. Smaller is W means your alpha T and alpha, gamma both rises. Both rises, alpha come closer to 1 and therefore beta, which is this, enhances. Is that correct? If alpha come closer to 1, beta also enhances. So if I increase reverse bias on base collector junction, beta actually increases. And this characteristics is telling me, if I move ahead VBC higher, these gaps are increasing compared to these gaps. Therefore, there is a finite slope of IC VC characteristics which shows that beta is changing with different VBC values. Is that correct? But this effect which allows this because of this is called Early effect. और यदि फिजिक्स जानना, फिजिक्स का नाम है इसका बेस विड्थ मॉड्यूलेशन. The base width gets changed means modulated. Modulated means modified, changed. Why it's called modulated? VBC is changing that. So control is VBC which is changing the base width. So we are modulating it by changing the VBC. So if I change VBC, I can change beta, therefore I can change IC to IB ratio as I see a different VC value. This effect was called base width modulation and suggested by, first time did was Early, James Early, and therefore it's called Early effect. The importance of Early effect is obvious, but one interesting feature which they figured out, probably I may not be able to show you correctly unless I had done a good graph. If I do correct graphs, which I probably am not able to correctly do here, if I extrapolate any of the characteristics at different IB towards minus VC side, they all meet at 1 voltage. And this value therefore was named called Early voltage. However, is it clear? If I extrapolate the ICVC characteristics for every IB towards backside to this, they all meet at 1 value of voltage which is called early voltage. What is early voltage importance? Okay, tell me, is early voltage larger better or smaller better? Larger better. What does that mean? The characteristics will come flatter and flatter, okay. That's what ideally we were looking for, but I was not getting. So typical value of early voltage may vary from 50 volt to 100 volt. 100 volts. Is that clear? 50 volt to 100 volts, the early voltage will come. Larger it is, the flatness it will show. Okay. Now early voltage is decided by XD. What is XD function we wrote? Depletion layer width, if assuming step junction, twice Ks epsilon naught, of course 1 upon any ND because they both are like this, okay, into whatever VBC or this. Okay. So obviously Q, NAND decides the early voltage or XD. Is that correct? So now you have another thing in your hand. The gain of an amplifier beta, AC beta, is essentially decided by the base collector dopings. Is that clear? So when I design a transistor for making a new transistor or new IC integral circuit, I must find out what hourly voltage I am looking for. Based on this, but if I choose only this from there, I must look the other properties, how much NA and D may change and therefore leakage current may, ICO may increase if I do something else. So I must plan what I am looking for and what I can achieve. Is that correct? This is what word is called design. Design means I control one, start losing second, oh no. Isko ye gaya. Some way how to match things is all the designers keep doing. Isko thoda badao, isko thoda adjust karo. That's why life is always combination of giveaway. Okay. Kuch to do. Okay. So this fact is very interesting. The another effect which is relevant here, anyway, ठीक है फिर से draw कर दो. Let us say, continuing with the same thesis, let us say I have IB0, no base current, or maybe take it very small current for the heck of it. Then, and I open the emitter. So I have only this. So what will happen? If there is no emitter open, there is no base current coming out, large number, small leakage, but otherwise no major current will come. No excess carriers are there, so no excess required from the base. So if I now say I increase VBC, what will happen? Since, okay, the dopings are so adjusted that never reaches to the base emitter. Let's say, okay, I increase the doping, depletion will not reach there. Remember, if I increase the base doping, depletion layer width will be smaller, therefore it will not reach this end of it. However, this is lighter and depletion layer may start enhancing, okay. And then at some voltage of VBC, what it can do, it may punch this. So, I may actually see large collector current because base collector junction is punched. Alternatively, even if this is wider, let us say, it's not punching, but at this base collector junction, the electric field is, because you are increasing VBC, the depletion width is enhancing, so your electric field is also enhancing. Which effect can then come? Avalanche. Avalanche breakdown can also occur if, let's say, your collector length is too long and it never gets punched. Okay. But even then, this kind of characteristics will be seen either by avalanche or by punch. However, if I increase base current, let us say slightly higher, I find the breakdown value which was here is shifting to the left. That means its breakdown becomes smaller. Why? Can you think anyone? If I have now base current flowing, that is base emitter junction is forward biased, some current is flowing in the base, why do you expect it to have a faster breakdown, earlier breakdown? How the breakdown occurs? If you have a larger base currents, is that clear what I am saying? That means charges in the base were higher. Those who are transiting in the base collector junction depletion layer are also large in, is that point clear? I repeat. If there are larger carriers here, this is my depletion. If I have more holes entering depletion layer, the avalanche, that is multiplication, will be quicker because you are already, earlier it was only reverse leakage current, so fewer carriers, so they take longer to multiply. If you are already having large carriers present to the depletion layer, then they may and the field is higher, then they multiply faster or more in quicker time, and therefore breakdown may occur. Is that power clear? Larger the base carriers you create there, if the carriers reaching collector are larger in number, the M number can reach earlier, and therefore avalanche may come earlier than zero base current value. Is that correct? So sometimes larger base current can create the breakdown characteristics. So the uppermost limit which you can go probably was from the given base current, what is the maximum breakdown you can attain to? Is that clear? So this is also one limitation which device has to bear this limitation, because in a circuit you must obviously know what is the maximum value that I can use, and what should you actually use? 70% of whatever maximum someone says. Why do I want to 70%? First is 10% variation is always there from device to device. 10% temperature variation is going to come. Okay, 10% safety रखो. Okay, और कुछ हमको नहीं पता हो रहा हो तो उसको भी दे दिया. तो 30% तो भी बाहर रहो. और सेफ रहना चाहो, जैसे सिविल वाले करते हैं, एक बीम का यदि बेंडिंग मोमेंट निकालने का पता लगा कि इट कैन टेक 1 ton लोड, दे डिजाइन फॉर 10 tons, क्योंकि पता नहीं 2 आदमी ऐसे हो गए जो 10 बन जाए, इसलिए लेट्स नॉट गेट इट. ओके, एंड व्हेन दिस डजंट हैपन यू सी ऑल ब्रिजेस फॉलिंग डाउन. दैट्स द प्रॉब्लम. So derating is very important in engineering. Do not give it. In circuit, never believe these manual values, because manual values are typical values. They are not for every device. Is that correct? Typical is neither max nor min, somewhere. So most of them. But which one you are using, you don't know. The minimum one or maximum, you don't know. So always keep the 70% safe side. Okay, so that never fails. Okay, so these are two. Sir, can you think temperature effect also on this? क्या चेंज हो जाएगा टेम्परेचर में? सोचो जरा. सब जगह ये टर्म आ रही है, सब जगह ये टर्म आ रही है. इतना ज्यादा टेम्परेचर बढ़ाओगे, लीकेज करंट प्रोपोर्शनेटली बढ़ते चलेगा. इज दैट करेक्ट? वाई QADP PNO. PNO is Ni square by Nd. Ni square rises as e to the power QEG by KT, EG by KT. So larger the temperature, larger is the leakage currents. Is that correct? So as leakage current increases, part of the carriers which should not have come from collector may now come from collector side also. You know, we are always neglecting reverse saturation current of collector base junction, but that may become dominant then. So these carriers may actually recombine through this, but no base current. Is that correct? So beta may fall suddenly, you may find. Because huge currents came from the collector side to the base, they got recombined. So the base current essentially is not because of the holes coming from P side, but coming electron holes coming from the base emitter, base collector. So temperature also has a very strong influence. What else it can change temperature? D's. KT by Q mu. Mu changes with temperature, D changes with temperature. Is that correct? So all and all devices show very strong exponential temperature dependence or squared T to the power 3 by 2 dependence in any characteristic you draw. These are the major limitations of a device in circuit. Okay, where do you operate? At 175 degree, what did I say you? A PN junction does not remain a junction. Okay, both side equal carriers. So क्या होते हैं उसको intrinsic बोल. So no diffusion, everything is same resistor. Is that correct? So I square R भी loss ही है, कोई device नहीं. So the maximum temperature which a device, bipolar device can operate is 175 degrees is the uppermost limit, but never reach there. So what is the maximum you should allow? 70% of that, at least 140, 150 degree तक ही जाओ. इससे ऊपर मत. क्या कैसे बचाएंगे टेम्परेचर को? What do we do in real life? If you have seen a transistor, most of the older transistors used to be a metal cap. आजकल ceramic caps. पर आप यदि देखा हो कि बोर्ड है उसके नीचे ऐसे हीट सिंक्स लगाए जाते हैं. वो क्यों लगाए जाते हैं? Because the overall board should remain cool. उससे भी नहीं हुआ तो क्या करते हैं? फैन ही लगा देते हैं. उससे भी ज्यादा अच्छा रखना है तो लिक्विड नाइट्रोजन का जैकेट डालते चारों तरफ और कूल कर दो. कूल करने से और क्या फायदा हो सकता है सर्किट में? तो जो क्या और कूल करने से और भी कुछ थिंग्स कूल हो जाते हैं. नॉइज. Noise is KT related noise. Lower thermal noise. So basic noise itself is lowered if you have lower temperatures. So the effort क्या रहता है कि liquid nitrogen के जैकेट में सब रखो. But then it becomes so very costly. तो यूज क्यों करें? वो जैकेट ही कॉस्ट ले गया आपको. इसलिए ऐसा नहीं करते, but otherwise the device will operate best if it is cooled heavily. Okay, this is something you should know from the circuit side. Yesterday I said so far we were assuming dN by dt or dP by dt 0. Tomorrow you say they are not 0. Time क्या होता है फिर? हर time पे क्या दिखेगा मुझे? What does it means? I want to see AC equivalent of that. What is the AC equivalent circuit for a transistor? Because I want to see gains. Okay. So avalanche, analog circuit का part देखेंगे tomorrow.